We are PSU UAS from Penn State University. In this review, we go over our preparations for the AUVSI SUAS competition.
Hi, I'm Jesse, and I run manual classification for the flight line.
Our system is built on a Skyhunter 1800mm kit. The fuselage has sufficient space for onboard hardware. Our camera is mounted on the nose, far from the pusher motor to mitigate vibrations. The powertrain uses a 6S 5000 mAh battery, a 60 amp ESC, a 3520 Cobra motor, and an 11 by 7 inch prop. The communication system uses a Spectrum receiver and transmitter for manual control, 900 MHz radio for telemetry, and a 5.8 GHz ubiquity system for imaging.
Hi, I'm Luke Sargent. I'm team captain and flight coordinator. The team is competing on obstacle avoidance and object detection, classification, and localization. The team will also be attempting to fully meet the autonomous flight criteria.
Hi, I'm Nick. I run avionics on the flight line. Development testing started with the online tool eCalc. eCalc was used greatly in scoping out kit planes. The Skyhunter 1800 met all mission requirements and was chosen as the final plane. After receiving the kit, the plane was converted into a CAD model. CFD analysis confirmed the viability of the plane for the mission. The CFD additionally improves the autonomous flight by estimating the plane's flight envelope. We were able to limit the number of flight envelope tests by taking values from CFD and testing them. This is more effective than tuning from scratch.
Hi, I'm Sam. On the flight line, I run backup avionics and help with manual classification. Autonomous capabilities are enabled by the Arduplane firmware running on a Cube Pilot flight controller. Before autonomous modes were utilized, the team conducted 3 manual tests to tune the plane. This included PID tuning, manually tuning the mixing, and flight envelope testing. Each manual test was analyzed with a custom Python script to predict the correct parameters to use for the autonomous modes. The team conducted 21 autonomous flights. There were 13 auto takeoffs and 5 auto landings. All other takeoffs and landings were manual. The plane has 151 minutes of autonomous flight and 218 minutes of manual flight. To help explore the autopilot settings, the team performed 16 autonomous flights on a Bixler 3. This enabled faster and cheaper development before finalizing the autonomous parameters on the Skyhunter.
Hi, I'm Alex, and I run the Ubiquity communication system. In order to prepare for autonomous flight, the team tested more than 400 waypoints and only missed one by more than 100 feet. Our average waypoint error was only 22.2 feet. Obstacle avoidance was measured on synthetic data. The avoidance algorithm can output a collision-free path for over 20 waypoints and 20 obstacles in under 1 second. During our mission demos, the plane avoided 5 obstacles with a 100% success rate. Imaging performance was calibrated on a multi-rotor before the design was added to the plane. At 250 feet, the ground resolution is over 2 pixels per inch. Shutter speed is the only manual exposure setting. The auto settings from the HQ Pi camera gave good results.
Hi, I'm Rishi. I monitor onboard payloads and the imaging system. Detection is evaluated on synthetic and real images. On synthetic data, the detection pipeline found over 1,000 targets with no false negatives and 1 false positive. On real data, the detection pipeline found 18 targets with no false negatives and 1 false positive. On synthetic data, the classification pipeline achieves an average of 99% on all tasks and has an average angle error of 12.5 degrees. On real data, the classification pipeline achieves 70% on all tasks and has an average angle error of 44 degrees. Localization is done during detection. The center of mass of the detection is projected through a camera matrix, view orientation, and position to find where the pixel intersects the ground. The vision pipeline localized 18 targets with an average error of 15.3 feet.
Hi, I'm Matt, and I'm the safety pilot and the launch and landing director. The team completed 2 full mission demonstrations. We made 9 targets with difficult color combinations and ambiguous letter orientations. We flew both mission demonstrations between 100 feet and 400 feet altitude and stayed within the boundaries of our flight field.
Hi, I'm Steven. I monitor the airspace for possible collisions with other teams and support the safety pilot for launch and landing.
Our first demonstration scored 59 and the second demonstration scored 65. The team is pleased with our scores. Improvements from the first to the second demonstration show successful iterations of the design. Notably, the imaging settings were refined, and the plane's PID tuning was improved to fly smoothly during the imaging task. Thanks for watching our flight readiness review for the AUVSI SUAS competition.